In this video we'll look into the differences between light bulbs and LEDs and how to make an LED behave more like a light bulb so you can use it as a replacement. Light bulbs and LEDs both give out light, but they work in very different ways. What happens if you slowly increase the voltage to a bulb? We see that the current slowly increases with the voltage until the bulb is lit. Now what happens if we do the same with an LED? Nothing happens at first, no current flows. Then at a certain voltage the current increases very fast and goes way over the LED's maximum current. Why is this? Well, an LED, as its name says, is in fact a diode. A diode conducts electricity in one direction only and with a very low resistance. An LED is like a normal diode, but it emits light as a byproduct, which is very useful. LEDs have a kind of barrier voltage which you have to overcome before any current at all will flow, and there's very little resistance, so the current increases rapidly. This barrier voltage is called a forward voltage, or VF, and it's different for different colour LEDs. This handy chart shows the various VF voltages for different colours and types of LEDs. To overcome this rapid current increase, it's normal to add a resistor in series with the LED. Now as the voltage is increased, you still have to overcome the forward voltage, but then the resistor limits the current as the voltage climbs, making it behave more like a bulb. Bulbs act like a resistor. The voltage applied determines the current and so the brightness. So a bulb can be made to work at a certain voltage and you can be sure that the correct current will flow because the bulb is acting like a resistor. But an LED is a diode, not a resistor. It needs to have a certain current flow to light to the correct brightness, but the current cannot be determined by the voltage applied unless a resistor is added, hence the series current limiting resistor. A good way to think about voltage and current is to think about water flowing through a pipe. The water level produces pressure, which is like voltage produced by the battery. The pressure causes the water to flow out, like the voltage causes the current to flow in the circuit. The more pressure that's applied, the more water will flow, and the more voltage that's applied, the more current will flow. This is the reason why we have to choose the right value resistor for an LED. What series resistor is needed? Fortunately, the value can easily be calculated like this. All we need to know is our supply voltage, VCC, our LED forward voltage, which we can find from the LED datasheet, and the LED drive current, which we can also find from the datasheet. Once we know those things, we take the supply voltage, subtract the LED forward voltage from it, and then divide that result by the desired LED current. So let's do an example. In this example we'll take 12 volts as the supply voltage and 2 volts as the LED forward voltage. So we subtract 2 from 12 and then we divide that by the current that we want, which in this case is 10 milliamps. So that gives us a result of 1000 ohms. So that's our resistor, 1000 ohms. This chart shows the different series resistors for different supply voltages and for a number of different LED colours. So in conclusion, bulbs need a certain voltage to work, and they won't work properly if the voltage is too high or too low. You have to match the bulb to the supply voltage correctly. LEDs need a specific current to work, and the current is determined by the supply voltage and the series resistor together. So they can work from a wide range of voltages as long as you use the right value series resistor. I hope you found that useful and enjoyable. Please leave me any comments you have if you want to know anything else, any suggestions for videos in the comments below, and please remember to like and subscribe. Thanks for watching.